I'm going to cover how to do correlations in Jamovi. Before you get started trying this yourself, you can see if you hit plus modules, you can see I added the module scatterplot, SCATR, and you can go through these menus and add it yourself to yours. Scatterplot is useful because we want to look at the data before we do correlations. Under Explore, you'll see I have a new option here, scatterplot, because I added the module. And I'm going to let's start with digits forward on my x-axis, digits backward on my y-axis. And if you look at the scatter plot, forward is on the x-axis. We're using it to predict backward. Every time, well, any graph in any science, the x-axis is your predictor going horizontally, and the y-axis is the outcome you're trying to predict. And you can see there's a linear relationship. I can ask for a linear regression line, and you can see the linear relationship between forward and backward digit span, that they're related. As forward goes up, you can predict backward. You can use the line to do it, right? So you can see a digit span of 8 tends to be paired with a digit span of 7 forward, right? We have this digit span of 6 forward, 6 backward. Each spot is a person in a scatter plot. I can also look at the relationship between, say, I can take backward digit span as my predictor on the x, and I can predict GPA on the y-axis. Here we can see another strong positive relationship, that as backward digit span goes up, so does GPA. They're related. We don't have to have a regression line in there. We can have none. You can still see the pattern. We can also see things that are unrelated. If you take age and put it in on the x-axis, you would expect no relationship. You wouldn't expect age to predict GPA, and it doesn't. But there's no systematic relationship here whatsoever. So scatter plots first. Look at the data before you calculate correlations. The next thing we'll do is calculate correlations. They are under the regression tab. Ask for a correlation matrix, and you can put them in any order, and it will take any continuous variable in Pearson R. So we can take forward digit span, backward digit span, age, and GPA, and we'll put them in here. We could add the Corsi block task, but I don't want the data set to get big and messy and hard to teach from. What we can see here is the Pearson R values. You can see forward and backward are correlated 0.648. That's significant. Means if you did it again, you would get it again. I like to take Pearson R. Pearson R is the degree of linear relatedness. You can square these numbers to get R squared, which is variance in common. So if the R squared were, if R was 0.5 and R squared was 0.25, so 0.5 squared, for the relationship between ice cream and weight, it means 25% of why your pants won't zip is the ice cream you're eating. 75%, right, 100% minus that 25, are other factors you didn't measure. So it's shared variance. Forward and backward at 0.65, that's roughly 37–38% of the variance shared. We can also look at GPA and backward digit span. All right, GPA in this phony sample data is correlated 0.7. You square that, that's 0.49. Roughly half of the variance in GPA is explained by these differences in working memory span size in digit backward tasks. They share half their variance, 0.7 squared, and it's significant. Correlation matrix is taken almost exactly as it is in the Jamovi output and put into an APA format paper. And these are pre-formatted to be copied and pasted straight into Word, and then you can edit the titles and the variable names to make them a little more meaningful. But that's it for correlations in Jamovi. So scatter plot through a separate utility, through the scatter utility, and then Pearson correlations under the regression tab.